Let's assume that you are about to start the flight. The APU is running and you require air conditioning. You are now in the cockpit, and this is how you find the air panel during your scanning sequence. Notice that, except for the off lights on the two PAC push-button switches, all the other push-button switches are in the normal lights out position.
One step of the cockpit pre-flight check is to extinguish all white lights on the overhead panel, so that you can watch what is happening. Let's have a look at the ECAM bleed page. We will now extinguish the PAC 1 off light by switching PAC 1 to on. Notice that the amber fault light on the PAC 1 push-button switch illuminates because PAC 1 is on, but no bleed air is available. We have pressed PAC 2 push-button switch to on. As for PAC 1, there is no available bleed air to PAC 2. Since you are expecting a standard passenger load, the PAC flow selector can be selected to normal.
Once again, there are no changes to the ECAM indications. The PAC flow selector only affects the PAC flow rate once the engines are running and supplying bleed air to the PACs. We will look at the use of the PAC flow selector later in this module.
It is now time to get some air to the PACs. As the APU is already running, we will set the APU bleed push button switch to on and watch the ECAM indications. Both PACs are now providing air conditioning. This is shown by the ECAM page indications and the amber fault lights, which have disappeared on the air panel. On the ECAM bleed page, the highest flow is automatically selected, regardless of the PAC flow selector position, because air is only supplied by the APU bleed system. Let's look at temperature regulation of the air conditioning system. This is better seen on the ECAM conditioning page.
Let us concentrate on the upper part of the ECAM conditioning page.
Look carefully at the indications. Notice in particular the zone temperatures and the duct inlet temperatures. Temperature regulation is achieved in the same way for all the zones. The cockpit and the cabin zone temperature selectors are in the 12 o'clock position. In this position, a zone temperature of approximately 24 degrees Celsius is demanded. Note, each cabin zone temperature can be optimized from the forward attendant panel. As the 16 degrees Celsius of all the zones is well below 24 degrees Celsius, the zone controller sends a command to increase the amount of hot air to be added. Due to this command, all the trim air valves open. The zone duct temperatures increase and so, warm air is supplied to the different zones and the cockpit and the cabin zones start to warm up.
In our example, the cockpit zone reaches the demanded temperature before the cabin zones. You can notice that the trim air valve of the cockpit zone closes progressively, reducing the amount of hot air in order to stabilize at the demanded temperature. Once the desired temperature is reached, this valve will move as required to maintain the zone temperature.
It is now time to start the engines. So that you can watch what is happening, let's go back to the ECAM bleed page. Note, normally the engine page is displayed during engine start. For training purposes, we will display the bleed page. Also, all cabin and cargo doors have been closed.
As soon as the engine start sequence begins, the PAC valves close. This is to allow all of the APU bleed air to be used to start the engines. Let's complete the sequence.
When the engine starting sequence is completed, the PAC valves open and The APU bleed supplies the pack flow high. Note, if either engine start is delayed more than 30 seconds, the packs will come back on automatically.
Notice that the engine bleed valves are closed, even with both engines running. This is because the APU bleed has priority over the engine bleed. So, if you were departing from a performance-limited runway, the packs could run from the APU bleed air, resulting in no loss of engine performance, no weight penalty.
However, today in our example, the APU is no longer required. When the APU bleed push button switch is selected off, the APU bleed and the cross bleed valves close. The link lines disappear and both engine bleed valves open, supplying the packs with bleed air.
As you can see on the ECAM bleed page, the pack flow automatically reduces. This is because the engines provide a higher flow rate than the APU. Also notice that the air panel is now in a normal lights-out configuration.
When the APU is shut down, all the APU indications disappear on the ECAM bleed page. Note, the white GND indication is always displayed on ground, even if the HP ground units are not connected. For more details, refer to the Pneumatic System Presentation module. During the flight phase, the air conditioning system will work automatically, and the only pilot input that may be required is to adjust the zone's temperature. Let us assume that you wish to cool down the cockpit by turning the cockpit zone selector. We have set the cockpit zone selector to cold. Because a low temperature has been asked, no hot air is added, and the cool pack output will supply the cockpit zone. Note that each increment on the zone temperature selector scale is 2 degrees Celsius, which gives a selectable range from 18 degrees Celsius at cold to 30 degrees Celsius at hot. In case of low passenger numbers, the pack flow selector can be set to low. This will reduce the bleed air consumption and therefore save fuel. On the engine warning display, pack flow low memo is displayed in green.
Occasionally, with a full passenger load and high ambient temperatures, it may be necessary to select high pack flow and cold to reduce the cockpit and the cabin temperature. Using high pack flow will increase the bleed demand from the engines and use more fuel. Once airborne, the pack flow selector should be returned to normal, and the temperature selectors adjusted as required.
After landing and engine shutdown, the system can be set to run from the APU or switched off completely, or an external conditioning unit can be connected via one or two low-pressure connection points on the underside of the aircraft. The low-pressure air is fed to the mixing unit and then into the 4 zones. There are no indications in the cockpit to show that an external conditioning unit is in use.